Hello and welcome back. Today we will be talking about population standard deviation. If you did not go watch my video on understanding standard deviation, the conceptual idea behind it, I would recommend starting with that video. Um, just like population variance, if you have not seen that one, we are going to discuss population standard deviation, which refers to finding the standard deviation of an entire population of observations. Cool. So, quick definition: standard deviation, the typical distance of data values from the mean. Again, it's your average distance any given value is from the average. That's wordy. This is a cleaner way of expressing that same idea. All right, here's our formula. And just like variance, I know it looks a little spooky. You should notice that this is actually the same exact equation as variance. The only difference is variance looks like this. Okay. And to find standard deviation, the only change we make to the variance formula is take the square root of both sides. So we take the square root of both sides, that goes away, and the right side becomes squared. Okay. All right. Some definitions in here. This symbol, I got to look up what it means, or what the Greek letter is. I don't know. But this is our standard deviation symbol, or our population standard deviation. What I believe to be Greek capital letter epsilon is our notation for sum of, also called summation. I'll make a note of that here. Summation. Okay. X sub I right here, this is each data value. We put the sub I because there's going to be more than one of them. Mu is our population mean. This is the symbol we use whenever we're talking about mean of the population. And n in the denominator here, the number of values or observations in the population. Okay. All right. Let's take a look at an example. This is going to look very similar, if not almost the same as population variance, except we're going to have one extra step at the end. But to review, here's the data set, 2, 4, 6, 8, 10, and underneath it, I list which x each observation corresponds to. So x of 1 is 2, x of 2 is 4, x of 3 is 6, x of 4 is 8, and x of 5 is 10, which I have listed here. And our n is 5 because we have 5 observations. And highlighted right, I'm going to keep the equation to the right side just so we can follow along what parts of the equation we're actually looking at. And here we're listing our x of i's and our n's. Okay. All right, so this is just the given information. Step 1, we find the mean, mu. So the mean is the sum of all of our x elements divided by the number of elements, which could be, this is a shorthand way of expressing it. You could also write it like this: x of 1 plus x of 2 plus x plus 3 plus x plus 4 plus x plus 5 over n, which translates to 2 plus 4 plus 6 plus 8 plus 10 over 5, which equals 30 over 5, which equals 6. So the average for our data set is 6, and that's this part of our equation right here. Step 2, find each deviation, which is each x value minus our mean, x of I minus mu. And that's this part of the equation we're focusing on. So x of 1 minus mu, our first x is 2. 2 minus 6 is negative 4. X of 2 minus mu is 4 minus 6 is negative 2. X of 3 minus mu is 6 minus 6 is 0. X of 4 minus mu is 8 minus 6 is 2. And x of 5 minus mu is 10 minus 6 is 4. Okay. Have all these listed out. Then we continue to step 3. We square each deviation. So we take the solutions that we found from step 2 and we square each one of them. So, and that's the squared. That now it's this part of the equation where we include the squared here. So I'm not going to reread all this again. Negative 4 squared, 16. Negative 2 squared, 4. 0 squared, 0. 2 squared, 4. And 4 squared, 16. All right. Step 4. Add the square deviations. Now, this is the part where we include our summation notation. I believe capital letter epsilon. Okay. And just like last time, I'm just going to draw a little line to show you what corresponds to what. So this part right here, that's where we get the 16. That's where we get the 4. That's where we get the 0. That's where we get that 4. And that's where we get that 16. And this is stuff we found from the previous steps. All right. So we add all these up now. 16 plus 4 plus 0 plus 4 plus 16, 20 and 20 adds to 40. So the summation of all of our squared deviations adds to 20. And that's right here. Okay, let's fix this. Step 5. Divide by number of observations n. So we take the number we found from step 4, 40 divided by our total number of observations, n, which is 5. 40 divided by 5 is 8. And just a note here, we just found the population variance. This we've done in a previous video. I'm pretty sure we got the same exact answer. We do one extra step from here to get our standard deviation, and that's step 6, take the square root. So here we have the equation written again. Here it all is. We know our numerator is 40. We know our denominator is 5. Square root of 40 over 5 equals square root of 8. Square root of 8 is approximately 2.83. In statistics, you're going to get a lot of decimal answers. Round however your teacher prefers. Typically 2 decimal points is fine. I know when I was a student, I liked to do 4 decimal points. In my mind, the more accurate, the closer the approximation of the answer. But once you get that far into decimals, it's pretty negligible. 2 should be fine. Anywho, the data values are typically 2.83 units from the mean. That means, on average, any given point is a distance of 2.83 units away from our mean. That's what this number here tells us, okay? All right, and here we have a practice problem. Find the population standard deviation for 1, dataset 5555, and 2, dataset 3, 5, 7, 9, and 11. All right, I'll give you a minute to pause here and take a stab at these. All right, hopefully you worked on them. Let's take a look. So the first one, simply 0. I didn't even show work. I was admittedly a little lazy here. But we know it's 0 because they're all 5. The mean is 5. Any given point is going to be 0 units away from the number 5. Anything is 0 units away from itself. So if you see something like this on a test, you should probably show your work. You could get wordy and write out everything I just said, but it's always better to show the mathematics. Your work should look something like this to show you how you got 0. But again, we could just look at this and know it's 0. All right, 2, we can't do the same thing. So here are our x's. X of 1 is 3, x of 2 is 5, x of 3 is 7, x of 4 is 9, x of 5 is 11. We have 5 observations, so n equals 5. If we take the mean of 3, 5, 7, 9, 11, we get 7. Now we square each x value's deviation from the mean. X of 1 minus 7 is -4. -4 squared gives me the 16. X of 2 is 5. 5 minus 7 is -2. -2 squared gives me the 4. 7 minus 7 squared gives me 0. 9 minus 7 is 2 squared gives me 4. And 11 minus 7 is 4 squared gives me 16. Okay, then we just plug that into our standard deviation equation. 16 plus 4 plus 0 plus 4 plus 16 is 40. Over 5 is 8. Square root of 8 is approximately 2.83, just like our practice problem. Cool. And that is everything I have for you on population standard deviation. Thank you for tuning in. As always, a link to the notes will be in the video description. And I will see you next time. Take care.